This is Mr. Weideman, and this is Lafayette High School, Functions in Trigonometry, and today's lesson we're going to continue with our Algebra 2 skills, and yesterday we did PEMDAS, order of operation. Today we're going to do laws of exponents. This is nothing new, you've seen all this before, but we're going to refresh ourselves, and then there's a few little tricks that we need to look out for. Some complications that we need to be aware of. But let's just start simple. We kind of know this. As long as the bases are the same, you just merely add the exponents. So I have this base of x, I have this base of y, so I can combine the x and I can combine the y and just simply add their exponents together. This is a little bit different than combining like terms when you're multiplying, and then there's your final answer. You just merely add together the exponents. Pretty simple. All right, let's look at something a little bit more complex. What if our exponents just happen to be fractions? Well, we can still add them. Okay, so what we need to do is we need to go 1/3 and add it to the 2. And how do we do that? Well, the 2 needs a common denominator. So it needs a common denominator of 3. So we turn the 2 into 6/3. And when we turn the 2 into 6/3, add it to 1/3, that is 5x to the 7/3. And it's just like, okay, well, what is x to the 7/3 really mean? Most of the time we'll just leave it like 7 x to the 7/3. But if you remember what we did back in the day with this thing, what does this really mean? This little guy right here will become the order of the radical, square root, cube root, fourth root, fifth root. This guy right here will then become the exponent of the term inside the radical. Probably not going to be using that a whole lot. If it's square roots, yes. A lot of times we're just going to leave things in this format right here. Sometimes when you want to look at the answer in the back of the book, it's going to have something like this. It means the same thing. It's just a change of format. Just be aware that you know how to do that. Okay, where's another example here? Okay, now what are we going to do with this? Well, now we really do need to convert things. Otherwise, it's really going to be complicated. So I have x to the 3rd, and then I have this x to the 7/3 power. So what we're going to need to do is we're going to have to add these two values. That means that the 3 is going to have a common denominator with the 7. So what is that going to be? That's going to be 9/3. That's the same as 3, but it's going to have a common denominator with the 7/3. So the 9 and the 7 will add together to give us 16/3. And that will be our final answer. Now, if you want to make that x cube root of x to the 16th power, that's okay, but not really necessary in most cases. Again, it's just format. And let's take a look at something that is a cousin to the product rule. It's called the quotient rule. And basically the rule is the same. Product means multiply. Quotient means divide. For the product rule, we add exponents. For the quotient rule, we subtract exponents. All right, so let's take a look at an example problem here. And before we go any further, I'm going to show you why this subtracting exponents works. You might have been showed this in Algebra 1. We call this little technique, when in doubt, expand it out. All right, and this is what I mean. Everything in the numerator, everything in the denominator is going to be factored completely. This gets a little tedious. You don't have to write this down. just follow along, just so we understand what exponents mean and why the quotient rule works. Okay, so I'm going to factor everything. There's the 30 factored. The x to the 12th power literally means 12 x's multiplied together, just like 7 y's multiplied together. Okay, and then I'm going to do the same thing in the denominator. Okay, now what's going to happen next? Well, I see some terms that are divided by itself. I see a 2 divided by a 2. I see 3 x's divided by x's. What's anything divided by itself? Well, it's just 1. So all these things in my term just make 1. 1 times 1 times 1 times 1 times 1. And what happens when I multiply things by 1? It doesn't change anything. So things, when we cancel things out, we have this tendency just to kind of sort of make them disappear. And when we finish writing it, that's what looks like what happened. But this is actually what's going on. And if we know what's going on, then some of these rules make a little bit more sense. Okay, so we obviously don't want to do all this. That's way too tedious, takes too much time. What's the shortcut? The shortcut is you subtract the exponents. Okay, and what's the rule? Okay, let's take the big number minus the little number. Right, so we are going to avoid a negative exponent. So I'm going to go to the 12 minus 3. The big number, the big exponent is in the numerator. So I'm going to do that operation in the numerator. And then I have this. I've got this 9, and I got this 7. So I want to go big number minus little number, 9 minus 7. But I want that operation to be in the denominator. And you might say, well, what am I talking about? All right, let's take a look here. All right, so the 30 and the 8 both can be divided by 2. There's the 12 minus 3. I do that operation in the numerator because the 12 is where the big exponent is. The 9 minus 7, I do that in the denominator because the 9 is the big exponent. Okay, in other words, I do not want it to look like this. I don't want this guy to be down there, and I don't want this guy to be down there. Okay? So we don't want it to look like that. All right, and then I can just simply 12 minus 3 and 9 minus 7, and I will get my final answer. And hopefully you remember that from Algebra 1 also. What are the big mistakes? All right, typically the big mistakes that students will make is they'll do a good job working with these guys, and then they'll forget to work with these guys. All right, find a common divisor. Don't be afraid to take a second step. If I do it once and there's still another step, don't be afraid to do it again. All right. Okay. What is our next operation that's going to be really important? Okay, this is a big deal. And students make a lot of mistakes about this, and there's a lot of mystique and confusion exactly what a negative exponent is. A negative exponent is actually telling you to take a reciprocal, meaning I take my numerator and switch it with my denominator, or vice versa. I know some of the algebra teachers like to call it bar hopping, to change your attitude. All right, and the bar hopping is just that division. It's that quotient line in a fraction. All right, so in this example right here, I have a negative exponent, so I need it to hop a quotient line or a fraction line. You go, well, I don't have one. That's okay. You can make one. You can always take any number, any expression, any polynomial, you name it, draw a big line underneath it, and put a 1 in the denominator. And boom, you've magically made a quotient line for negative exponents to hop over. Okay, so all I have to do that is make a quotient line, pull that into the denominator. And there we go. All right, let's do something like this. What if my negative exponent is in my denominator? What do I do then? You pull it into the numerator. Okay, and here, when I pull it in the numerator to turn it positive, I can multiply, and I get the x to the 11th. And then the 3 and the 9 can both be reduced. What if I have something like this? And now I need to take a little bit into account my order of operations. My order of operations tell me that I had to take care of parentheses first and exponents next. Okay, so that means that not just the x, not just the 3, but the entire term has a negative exponent to it. All right, so we need to take the entire thing to the denominator. This is something that we're actually going to see quite a bit later on in the course. All right, what does this mean? 2 to the negative 1, 2 to the negative 2, 2 to the negative 3. Well, if we get rid of the negative exponent, we draw a quotient line and we bring it underneath the quotient line. Okay, and then we can go 2 squared, 2 cubed, and we can get our 1/4 and our 1/8. So 2 to the negative 1 is actually going to be a half. 2 to the negative 2 is going to be a quarter, so on and so forth. And one more thing, and then we're going to have to switch to another video. And this says the same thing. Okay? I just drew a quotient line, put it all over 1, didn't change a thing. It just gave me that quotient line to allow me to take this term and move it into the denominator. All right? So that's showing more work than necessary. If you know that that's what it means, then by all means, make sure you take the shortcut and you just go to right here and know what you're doing. All right, I'm going to pick this up then on the next video.